Hello, this is Marek from the Artistry of Code podcast. I would like to welcome you to our 10th episode of our main series. This is the continuation of a previous episode where we talked about asynchronous communication challenges. We went today more into the details like out of order, ensuring delivery, retries and how they are connected with the idempotency, and also we've touched a bit on QoS. Enjoy!
Welcome to the Artistry of Code podcast, where we, together with our guests, are seeking ways of doing things right and having fun with it.
Software, architecture, soft skills, teamwork, and other crazy buzzwords.
Are you ready? Let's bring more value to the business. Hello everyone in this beautiful morning. Welcome in 10th episode of our podcast. Today we are going to talk once again about the same topic as previously, which is asynchronous communication, but this time we're gonna go into details more than last time. So we have a few things in the outline, but they will be coming soon. Now let's start, guys, from our last 2 weeks. So Marek, may you start?
Yeah. So to avoid any construction topics, I would like to share my recent experience at work, where I am dealing with the one of most beloved issues in the programming, which is about the time, dates, and the time zones. So yeah, this is the topic which everyone knows that it's hard for like 30, 50, 60 years, but it's still difficult for people who have to work with that, and I am one of them at this moment. And I have to say it can be really challenging, but in the end it's really interesting topic to work on. So yeah, I definitely encourage everyone to like give a try and figure out some maybe a synthetic time zone issue and try to work it out. And yeah, that's mostly it from my side. What about you, Arthur?
Yeah, I wanted to say thank God for all those libraries that help us handle all the dates and time zones, etc. Yeah, and also was good to hear, Marek, that you have some, professional, uh, professional things to share, not only from the construction side, because for some time I thought that you are already a construction site worker full time. Yeah, but it's fine. I also have some yeah, things to share from my work, and what drives me lately is finally some designing stuff. So we need to introduce some kind of business critical feature which is related to money. So the bar is raised quite high. We need to ensure that everything works as expected, and now we're trying to make it out transactional in TypeORM and Nest.js, and it's not the best connection, I would say. Yeah, we have a lot of complaints in the team about how TypeORM is integrated into Nest.js and how we need to do it on our own. Why there is no decorator? Why it's not recommended? This is the big question from us. And what about you, Grzegorz?
Yeah, it just made us laugh. In the video version, we're going at like Marek triggered overlay on that statement. Yeah, but when it comes to me in my last 2 weeks, I actually had the first opportunity to exercise event storming and strategical DDD in my day-to-day work, because previously, as you guys know, when we were working on the IoT project, that's not like a big process problem. But right now, when I'm thinking about solving some of the issues for the platform, I had to really recognize some of the processes, how they work, and event storming with like the sticky notes on Miro allowed me to go through the domain, unravel the important events, the bounded contexts, and then propose a solution to the problem, which was like very nicely aligned. So right now I have this all like designed, and now there goes collect the stamps competition, where I need to get enough approvals in order to proceed with this idea. So yeah, a different challenge in front of me. So yeah, that would be my highlight.
Yeah, that's super cool that you had an opportunity, but I must say that it's much better to do the event storming when you have the sticky notes and the real board, because when you did it online, then you missed all the fun that is coming from all those sticky notes not keeping on the board, and you have to place it once again, or keep stick one note to another, and then finally will land on the floor. Yeah,
Yeah, that's definitely something which is missing there. I was hoping for like running a workshop, but that would require me to travel quite a number of kilometers away, and also there's no much pandemic constraints, I would say, which would be prohibiting that, but people already adjusted their lives to that semi-remote style, and I thought it's going to be hard to gather everybody in the same room, but hopefully somewhere in the future we're going to run a proper workshop with those sticky notes falling off from the wall on the floor, allowing people to rethink what they just did. Perhaps the falling sticky note is a sign. So
or checking if people are focused, if they know where the sticky notes was.
yeah, where it were. Yeah.
Okay, guys, we proceeded like one by one synchronously. Maybe now it's the time to go back to asynchronous topic, asynchronous communication. So we can now start, talking uh, together whenever you want. Yeah, it's about asynchronous communication. So
I
we
bet it
wait.
wouldn't be that pleasant to listen when we would be talking asynchronously. So
Okay, so
we should stick to be
let's
synchronous.
stick to outline. Yeah. You convinced me, Marek. So we will start from the problem of ordering in asynchronous communication. So yeah, we touched it a little bit, told in the previous episode, the number 9, that there are situations when not all asynchronous communication will ensure us delivery of the events in the order that they were produced. So let's start with that. Yeah, do you guys know? Maybe start from the scenarios when the asynchronous communication with defined order and this business requirement to keep the order is crucial, and how to deal with it.
I would say that when you were mentioning the money related feature, it already came to my mind that we will be talking about out of order. And yeah, definitely when you are talking about the money, the order of the processing is like critical for many different reasons. But yeah, I think we can start from the very simple thing here, that the order can be ensured by the infrastructure we use, or at least at the if everything's go well. Yeah, so Rabbit can be FIFO by default, and it also applies to Amazon SQS, which can be also be easily first in first out. But yeah, I think this will immediately goes to the situation when everything is not okay, because we recently discussed this, I think offline, about the ordering and what's happened when not everything is going well.
So the broker used in order to carry the messages is, like you said, they most of the time and on all really rare occasions they're not like giving things out in order. But I would like to draw that picture a little bit wider. So I saw in the past the problems with out of order actually coming from the producer side. So it might be the case that if you're having an application which is batch processing something, and it's doing this in an asynchronous manner, I mean, in asynchronous code, sometimes some of the tasks finish faster than the other ones. So it might be the case that, let's say, your application is supposed to produce messages A, B, C, but due to the fact that you're, I don't know, like running multi-threaded or running concurrently, then the messages go out C, B, A. And this is what's being produced already out of order, right? So then the broker, for the broker, that's going to be the order. CBA is the order, right? So the broker is going to convey that further. Now, the other thing which may go wrong is on the receiving side. So that's something which we talked through offline last time. So if you have a single like consumer, which is a single threaded thing, and it processes one task at a time, it's either going to get the ABC if the producer sent ABC, or CBA if that's the broken order. Now, here, two problems may arise. So first of all, coming from the concurrency of the consumers. So we talked about the competing consumer example, where you have multiple consumers, separate processes, which are going to take those messages off the queue, and they will process this in parallel, which means that you may really process BCA at the end of the day in that sequence. And also the same problem applies when your consumer is like multi-threaded or running concurrently. Also, the processing can be done out of order. So I think that, like ensuring the order starts really from the producer, so that we are really taking care that the messages are going to be published in a proper sequence, and on the receiving side, that those messages also will be processed in order.
Yeah, that's true. That producer can do a mess initially that it will be hard to then handle in a proper way. But I also wanted to put the ordering thing in some right context, because usually the context is not for the whole event stream. Yeah, let's call it event stream, even it's if a queue. It really doesn't matter. Yeah, you when you put their events and require the strict ordering, usually the strict ordering is connected to some state of some entity. And let's say we have those entities a lot in the system. Yeah, and in case of IoT system, we have some devices that have some state that we should maintain by those messages flowing in. And for me, the ordering is usually connected to a single entity. Yeah, so it's crucial for us to keep messages in order if they come from the same device, or are about the same entity. If the order between events coming from different entities is not maintained, it's usually not that crucial, and we usually don't need to focus on that. So even if we have like concurrent producers that can produce the out of order on the very beginning, I feel like we can still fight with this problem by using some additional properties of messages. Yeah, like the time when it was produced, and having a solution like synchronized time on servers, which is now possible with this time servers being available widely. I think that this is a solution that we can handle even in this non-friendly environment.
I definitely agree that there is at least few strategies to mitigate the concurrency issue and ordering stuff. It can be also done on using the sharding approach. So the different the different streams can be sharded between different queues or streams, doesn't matter on the naming. But also sometimes when we thought about this CBA thing, sometimes we may have to sacrifice some performance, maybe maybe only consume one message at the time, just for the sake of consistency, because we have to for some reason, and we cannot, for example, discard the message as you mentioned based on the timestamp, because we don't care about it if it's old, like in IoT systems. And this is sometimes the good way. Yeah, just it can be a bit slower, but we can be then 100% sure it will be consistent.
In some systems, you even don't have the other choice than put the one consumer. And yeah, we mentioned it in previous episode. For example, Kafka and Event Hub, which is the very similar product but from a different cloud provider, will also not allow you to have more consumer. But yeah, in Kafka, for example, you can do the partitioning. So Grzegorz last time introduced us what the partitioning is. It will help you scale the application, so reduce the problem of performance. And on the other side, per partition, the ordering will be maintained. Yeah, so this also tackles the thing that I mentioned, that usually the order needs to be it is bounded to some context of some entity that we are changing by this event.
So what I wanted to just bring up is that at some point of time somewhere in the past, I've recalled the idea that if we had a very high prefetch count set on the queues, in order to make sure that we are processing messages more or less in order, the idea was to switch the prefetch count to 1. This is going to give you the in order processing, because you will reduce the batch size which you're using, and that's going to limit the surface for the concurrency issues to happen. But what I wanted to quickly also comment on is that the case which you've mentioned about having a single consumer, right, on a Kafka or an Event Hub. Uh, as a consumer, you control the batch of the size of the batch. And it might be the case that you will receive like 1,000 of messages, but they will be related to 500 different customers. So then, what you need to do in this sort of a situation is that you need to separate those events in order per customer or an entity which you're processing, and then process each and every substream, let's call it, of those messages or events concurrently in order. So the scalability of this is very entertaining, I would say.
Yeah, definitely. I would say that it will all go back to the previous episode when we talked about choosing the right solution based on the business requirements. Yeah, so it all has to be selected and like adjusted, all these scalability solutions based on what business really needs from us. Yeah, if it's more performance or it's more consistency or anything.
Yeah, but Grzegorz, you mentioned about the consuming like 1,000 events at a time. That's true, and we have done it already to separate those streams to streams per entity. And it might be a good idea to process it asynchronously, but it's also a very hard to implement idea in terms of keeping the transactional processing. Yeah, because then putting it those events to process concurrently will make it harder. Like if you will, for example, put it into another thread or another process to another application, then you're introducing the complexity of potential revert. Yeah? If you will need to revert 1,000 messages, which are, I don't know, for 100 entities, then it may end up as a total mess and actually unreversible changes. So then without the idempotency, we are in really big troubles. So I think that if we consume more than one event per single, like consumption cycle, then we need to ensure that our transactional system is working perfectly. Or we have some other like strategies which will prevent the data loss, or will prevent the additional application of the same message on the entity. And we also know some tricks, like for example keeping it in Redis, because Redis has quite nice data structure for ordered data, like sorted set, for example, that will allow you to put it there in terms of problems with processing, and then getting it back as a retry, internal retry. But and I also wanted to say that if we will limit the processing to one, what you Marek said, and keep on the next, like the consumer will, for example, push it to another place. And if we want to make it secure, then we need for example a committed transaction on database. Or if we push it to another queue, then we need a confirmation. And here we are slowly getting to the topic of confirmation the data that message has been delivered, and ensuring that it's safe.
So I wanted to sort of wrap up that part, and I wanted to raise 2 points here. First of all, I think it's also worth to mention for our listeners that there's an additional question that they can ask while thinking about the which of the systems to take, specifically when we're talking about like an event stream and queuing. Because when you're taking messages off the queue, you can a message, so acknowledge a message one by one. But when it comes to the event streams, most commonly you get a batch of events, and then if you have a 1,000 of message like events at your hand, what will you do if only one of them or 10 of them will fail the processing, right? So for those event streams, it typically works in a way that you're moving a cursor after you processed all the messages from that batch, which poses a totally different difficulty for the implementation side, right? So that's also a question you can ask yourself: should I be able to act each and every message after I'm done with it, or the batching behavior is going to be also okay? And the other thing which you've brought, Arthur, which is very nice, is that in order to ensure the delivery, and I'm looking for some pro tips for our listeners here, if you are having a situation that you would like to somehow figure out what's the order, one of the ideas is to run with the timestamps, right? So if the messages are somehow timestamped, you can use this in order to reproduce the order. The other solution which I saw in the past is using sequence numbers. So the producer, while it's producing updates for a particular entity, it's incrementing a counter. So it's like a sequence number for that like given entity, and this allows you to run away from the time zone problems, time stamping problems, from the problem of time, really, because you just need to maintain the counter. So you're going to increase that counter over time, and then you can rely on this to one point where the counter has to reset. There are some cases where the counter has to reset, so then you need to have a second piece of information, which can be used in order to figure out whether that's a new counting or old counting. And in the past, how we solve this, at least for some cases, is that we introduce a concept of sessions. So if there was a producer, sending out messages, start counting from 1, and this producer reconnected, it kind of created a new session and then started to count again. So we were able to aggregate messages per session and then also identify which of them was older and which of them was newer, so that the ordering could be kept without using timestamps here.
You can also use the big int, like 64 bits of integer unsigned, and then the problem of resetting the counter is the problem of the next generation of programmers. So it's also some trick to implement, of course.
Yeah, that
I'm
sounds like
blinking an eye right now.
this sounds like this library should be called time bomb. So
Yeah, the clock is ticking. Yeah, but it's easier to predict when it will blow up. Okay,
okay.
so yeah, we already, I think, covered the problem of ordering. Now in the asynchronous communication, I suspect that we don't want to live in the PubSub jungle most of the time. We rather want to ensure that the messages that we send to other places, to other services, will be delivered and processed and not dropped somewhere on the way. So in synchronous communication, it's easy. You send requests, return the response, and we have the confirmation. How we can confirm and ensure delivery in asynchronous systems?
So I think that the first thing which comes to mind is the capabilities which the protocol gives you. So when I'm thinking about like MQTT or AMQP, they are allowing you to wait for confirmation for the publish, right? So the server on the other side has to acknowledge that, okay, I've received this information, this message. So it's sending like a pub ACK in MQTT, and this tells you as a producer, okay, I'm now ready in order to send my next message. Okay, but this brings a new challenge already, which is the fact that you're getting back pressured, right? So if you have a series of updates to send, let's say 100 messages, it's as a producer, now the server is going to tell you one by one if you're allowed to continue, right? So that's going to put the pressure back on you, because if you would like to be stateless as an app, you have to push it somewhere else. Otherwise, your process might get killed, and all the 1,000 messages in memory is going to run out, right? So the protocols, they tend to have this. So recognize what are you using and what kind of capabilities the protocol which you're using has for having those confirmations.
Yeah, to handle this back pressure while being sure it was published, etc. There is like pro tip, or at least a tip here, which can be used, which is the outbox pattern, which is not super easy to implement, as we know, but can be definitely be used if the delivery has to be ensured, but also that the main service can still be more or less stateless, and doesn't be held back by the broker this way.
Yeah, I like that you guys raised the problem of confirming on the um, producer side, because I feel like usually it's the thing that people don't pay much attention to. Yeah, they expect that if they will push, then the queue solutions like Rabbit or Kafka will just keep up the pace without a problem. While it's not always the case, and we have seen it in our experience at least once, that the back pressure was so high when we were like implementing the pattern of confirmation, that the whole system has slowed down. And yeah, we saw we said at the previous episode that when you have asynchronous communication between your services, then the whole solution is like maybe not scaling, but keeping the same pace. Because if the next service will not respond, then the first will not accept another request, and everything is processed in the same pace. So here is the same behavior, that by applying back pressure and the confirmation channels on producer side, you will also be sure that there will be no like the inflating the balloon, between those services, which can like pop in some situation. And I feel like not applying these back pressure strategies is the main problem of RabbitMQ servers being down. why they in some situations stop working. Usually is because they are receiving too much, and in the end of the day they just are running out of memory.
Yeah, but then again, they are defending themselves from it, right? So you have that flow state behavior. So the broker is slowing down the publisher, and to some extent, that back pressuring is already there. But then again, I think it's really worth sharing why we really like had to switch to the confirm channels. In our case, when we were using the Node.js, and one of the most popular libraries for this, the MQP lib, we've run into a problem which wasn't like super transparent for us in the first time. And the problem was that when you're as a publisher trying to publish hundreds of thousands of messages per second, it's not the case that all of them get immediately accepted. As a matter of fact, IMQPlib was maintaining an in-memory backlog of the messages to send. So your code was already thinking that I was done and that message has been sent, while it was really not the case. It was still within your process and not on the broker. So in order to be sure that I can really move to the next task, we switched to the confirm channels, because this was forcing MQPlib to push things out and tell us that we are done when we really were done. Otherwise, we were having situations like, okay, your process is getting out of memory kill, or simply gets terminated without waiting for all the messages to be sent out, because your code even doesn't know about that backlog. So that was pretty much a lifesaver for us.
Yeah, but it came with a cost that probably everyone will see. In our case, we saw like a drop of 1 0 in the numbers, of publishing messages, and you guys need to remember that you should expect that. Yeah, and that the fact that you're pushing without checking if it actually delivered doesn't mean that it's the right pace for you. If you want to be secure, then the price is the performance, and it's always there, because it's a matter of just a time which is required to send the data over the wire and go back, with confirmation. While without confirmation, it's just pushed like in this PubSub. if it will be delivered, it's then the second not that important factor. So except for the back pressure and confirm channels in some solutions, in another, like you mentioned, Grzegorz, MQP, for example, but as far as I remember, so also in the MQP protocol, we have a QoS, which is quality of service, and it's on a producer side, so the producer can decide what type of, let's say, level of certainty of delivery he wants to achieve. And as far as I remember from MQTT, you have QoS0, which is like fire and forget. It's the most performant, but will give you no guarantee that it will be delivered. We have QoS number 1, as far as I remember, which is like at least once delivery, and we have the most strict QoS, which is the exactly once delivery, as far as I remember. And this pattern is also in AMQP. I don't know. I don't remember if in the details it's very same or similar, but we can assume it's very similar. And have you guys used it on a daily basis? Because we, as I remember, always usually stick to the in the middle to QoS1, and it's used to work fine. But yeah, it comes with a price that you need to make sure that either your events are idempotent or you will drop the second delivery, right?
So when it comes to RabbitMQ, I've never was playing with the QoS. So from what I see in the documentation, it's an extension which can be done on the consumer prefetch. I didn't see anything quickly on QoS when it comes to the producer side. So something to investigate and check. So I would say that when it comes to this area, most of the time probably sticking to the defaults, which are perhaps not even configurable for me.
You touched important subject, Arthur, I believe, which is the idempotency in the events processing, which can be crazy hard to get, at least in some cases. So yeah, maybe to quickly explain what is idempotency, if some of the listeners maybe don't know the term. It's mainly about making the system being capable of consuming or processing the same event or command twice or more with the very same result and without the issue when processing it again. Yeah, and when it comes to the idempotency, the one challenge which I definitely found in recent past is about the notifications and basically the side effects of the event or the command, because yeah, it's manageable to get the event processed correctly twice or thrice, doesn't matter. But what if this event processing results in triggering, I don't know, push notification or something? And I believe most of us seen some applications like spamming us at some point with thousands, or maybe not thousands, but dozens of the very same push notifications, and we don't want to do that. So it's really challenging to handle this kind of side effects while trying to be idempotent, which we have to be if we are in the environment which is at least once delivering.
Which is a super big problem in microservices with separate teams. While sometimes when you're publishing an event or processing something, you might not be even aware about the effects of that event happening on other systems, right? So you just declare that I'm going to process that request. I'm going to send something, and there's the notification service and the notification team, which are reacting to this. But then again, if you have this problem, that probably means that the design is not right. So the system and the way things are sliced business wise are not there's no alignment there, right? So if this sort of operation spans to multiple microservices, that's most likely a problem, I would say. I was recently reading an ebook from O'Reilly. They produced a nice ebook which you can get really for free, and it's a description of I believe it was like 5 main architectural patterns. And for the microservices, this example was precisely used in order to depict some, like pitfalls when it comes to use that, right? So they did proper slicing with the business might be the answer here.
Yeah, this is one side, but I believe that is also some mitigations can be done on the producer side, because, for example, if the design is correct and everything is handled as expected, for example, if we would think about to-do list and we want to send the notifications on every task being completed, but in separate microservice, because it's so cool to have different service for notifications. The producer can consume twice the event about the event which is making the task completed, let's say. um, and it can handle properly the publishing of the task completed event, yeah, based on the current state of the entity, etc. So it won't change the state in something different. It will be idempotent, but it won't publish the very same event again because it was already there.
And there's the thing, yes and no, because when I'm looking on our outline, the other point which we wanted to mention is the at least once delivery, right? So the at least once delivery of messages means that there are some systems which are having this trait. And what it means is that you, as a consumer, you need to expect that this message might come to you multiple times or at least once. So we're going to do everything that to ensure delivery of that messages to you so hard that you might get it twice. So this is where the idempotency part kicks in really strong. And again, I'm not sure how from your experience, but I think that most of the time the at least once delivery guarantees are provided either by like systems which are technically implementing this, or when we were referring to like pops up queues and event stream. I think that's mostly common with the event streams, that you need to expect that at least once delivery behavior, which is not there in the other cases, right? So that's also one of the challenges which we see when it comes to the asynchronous communication, that you might have this delivered twice and not due to the producer, really, right? That might be due to the broker technology or the infrastructure component.
Okay, guys. So I feel like all the ensuring delivery and this quality of service thingy, confirm channels we have covered. The last thing that we have in the outline is the message processing by long-running processes, if they should be a part of the asynchronous communication or not. To be honest, I don't have much experience in it. I didn't implement a lot of those long-running processes. Um, but I did one recently. It was like about doing some query to the data lake. Yeah? But in these terms, this long-running process was a publisher and this communication. So it was quite easy to implement. Yeah, just to gather the data, process it in the pace that was possible by the solution, and then produce the event stream to Kafka. It is very easy scenario, and I think the what we would like to tackle here is that if long running processes can be consumers, how do you feel?
I would say they can, and in some cases it will definitely be good for some reasons, like maybe ease of monitoring, for example, because if the long it also depends what we will define as the long running process, yeah, because in some cases the long running process can be anything which will last more than, I don't know, 100 milliseconds, yeah. If that's something triggered from the UI, you don't want to show the spinner to the user, like, which will spin for 30 minutes or even 30 seconds. um, yeah, and I can recall for sure a few examples of long running maybe it's not long running process, but on the application level, but it's sort of the process which has to wait for the results from the third party. Um, and it can be also done nicely with the queues and the async messages, async communication brokers, because in this case, like instead of using the internal timers, which will easily fail in case of any process exit or something, and we can lose the track, for example, of the retries. The retry, or I mean the retry of asking the third party, "Hey, is my result ready for me?" It was done by retrying on the queue system, and basically when we checked that okay, it's not there yet, we were knocking with the delay, and
Okay.
sorry.
So like a polling implemented on queues.
Let's say so, yeah. But as the result is can be sometimes heavy to process, it has to be because it has like many different side effects. It's important to have it like scalable, yeah. So any consumer which is free to process can consume, and if the result is ready, it will pick it up and process, yeah. So yeah, this is sort of long running process approach which can be done with the queuing system.
Yeah, recently I saw other example of usage of long-running processes, and this one was connected rather with the thing that part of the process was based on the human interaction. So, for example, starting a payment, yeah, sometimes it's fairly easy. Sometimes it's made automatic with all those new systems that have some kind of remembering you, assuming that it's secure, etc. But sometimes when, for example, the 3D secure kicks in, or you need to type like as a client something on application, then the process may take a long time, and it's not a good idea to wait till it's done, and then the asynchronous implementation kicks in. And I have been working recently with Stripe as a payment provider, a subscription provider with possibility to pay. And they also use the same approach to other processes that they need to ensure that is being done transactional in their system, but can take longer than accepted HTTP timeout. And they just defined the uh, webhook implementation, so you could like attach your own endpoint, and their asynchronous system just notified you about the finishing of the process. And I feel like we also implemented in our like in we have shared memories of the very similar pattern. So we are acknowledging that some request has been accepted, and then it was like asynchronously executed on our side, and IoT, just not to make the user wait for our work to be finished.
But then again, the feedback channel existed, right? So we had
Yeah,
like
yeah.
a CQRS like implementation where the command is accepted, it's getting processed asynchronously, and then when the change goes to the source of truth here, right? So that in our case that was a device. So if the change was really applied on the device, then the confirmation came in form of a view or in form of a live update being sent, right? But then again, this is the other point which we have here, which we wanted to talk about, is that let's stay with that example which you've just brought to the table. That sometimes the command execution or the underlying process takes a lot of time, right? So, what kind of best practices we would give for our listeners to deal with that, and how to communicate that failure of that process back, or how to communicate that the process really timed out. Let's say you have like 3 minutes to apply the change. If the change was not applied within 3 minutes, how will they know if the change wasn't applied due to a failure that they made or something, or perhaps the processing of the response from the device takes too long, right? So I'm looking for those cases when we are shooting at the API and then trying to get the feedback correctly back.
Yeah, I would just give, before we go into the details how to handle the result, I would say that always remember to tell the user that you just accepted and you didn't process, which is 202 in HTTP. So don't lie to the user, it's okay, or it's created or something. Tell them it will be long running process and it's 202.
Success true.
Yeah.
Success true.
Yeah, that's probably the best idea, at least if you use the synchronous communication. Yeah, because if the request is or the command is sent via asynchronous communication, then it's like the producer is expecting, right, that the response to it also will be asynchronous and can take time. But when it's really asynchronous, like you call an API and then it triggers some asynchronous job that takes time in the background, then what you said, Marek, is the right way. So I would recommend returning some kind of request ID with the status telling that it's being accepted to process. I would then expose also the endpoint of this HTTP API to check the status, check the result of this process. And finally, I would set up some async communication channel like webhooks, or if it's a front end, then WebSockets is also good, or even some pub subsystem that will send a notification when it's ready. Yeah, because this notification usually can be optional. Yeah, if the user or the client system is really interested in the result, and it should, in my opinion, take care of it on its own, not rely only on the webhooks that can fail, that can be not delivered because of some reasons. um, so that is the solution that I would apply.
Yeah, that's a nice solution in terms of especially of providing like two feedback channels, which brings me like to the way how, for example, the socket IO works. So when the client is capable of handling WebSockets, yeah, it will use the WebSockets and it will use the live feedback. But if it's not capable of handling WebSockets for any reason, it will use polling. Yeah, so that's good approach always from I would say that like either for the front end or either from the external clients of the API, like provide them if possible with two ways of getting the feedback, so it's easier for the other developers to integrate with your solution.
We had an assumption to make it in 40 minutes. I feel like we still can accomplish it if you, the listeners or viewers, will set the playback speed to 1.5.
Yeah, we successfully failed.
Yeah, we successfully
Successfully
failed.
failed.
Yeah, so we have all of our outline covered. Yeah, we talked a little bit. Yeah, Gregor?
I have one additional point. That's
Wow.
actually a revelation from like 2 or 3 days ago, because I'm thinking about integrating SAAP, and they're having a solution for asynchronous communication called Event Mesh. And I was very surprised about one of the ideas which is applied there. Something to probably comment on in future episodes. I just want to share this as an insight. They have implemented REST API for events and for messaging, so you can implement your consumer as an API client who's going to collect those events from REST endpoints. So that's REST communication without using brokers. So it's like the brokerless asynchronous communication implemented this way. So that I was very intrigued when I've read the documentation of that you can do it over the REST APIs. I wouldn't figure this out myself this century, I would say. So
yeah, it's a time of WebSockets, so everything is possible. Yeah, okay. So I think now we tackled all our topics from outline. So we would like to ask you, our listeners and viewers, to share your experiences on how to do an asynchronous communication, how to cope with all the problems of ordering messages, of ensuring delivery, and how did you implement long-running processes if you use the asynchronous communication? If not, how you did that? So we would be glad to see some comments, to hear from you. Having this said, I think it's all for today. So thank you for your attendance and see you next time. Bye-bye.
Bye-bye.
take care. Bye-bye.
That's all for today. Thanks for spending your time with us.
Visit our page on Facebook and Twitter, leave us a comment under the episode, subscribe to the updates, and share it with others.
We would like to hear your feedback so that we can prepare more interesting content for you to enjoy. Hear you next time!